So guys, now let's look at more practical questions. And through these questions, I'll be explaining things that I've never explained before. So don't be surprised if you see something new. Just take it as it is and learn on the go. So this question says that a body of mass 58 gram is suspended at the 20 centimeter mark of a uniform meter rule. So one thing you must know is that if you are given question on a uniform meter rule, that is 1 meter, that means the meter rule is, of course, 1 meter long and is what? 100 centimeter what? Long. You understand? So a meter rule, nobody needs to tell you that it's 100 centimeter. Just know that in your mind that if you are given a question involving a meter rule, it is what? 100 centimeter long, or 1 meter long. But we use it in centimeter, 100 centimeter long. But if it is not stated as a meter rule, they will surely give you the what? The length of the wood or the plank or the ruler as it may be. So that's one thing you should note. And another thing you should note is that the center of gravity of a meter rule is a 50 centimeter mark. The center of gravity of a meter rule is on the 50 cm mark. That's one thing you should know. It's on the what? On the 50 cm mark. So now what is the center of gravity? Center of gravity is that point in a body or an object where the whole weight of that body appears to be concentrated on. You get? It appears to be concentrated on. I want to use something as an illustration. Now, if I'm holding a flat board and I want to spin it on my hand, where I'll put my finger that I'll be able to hold it without it falling is the what? The center of gravity. And it is that point where the whole weight of the body appears to be what? To be concentrated on. So the center of gravity of the ruler is what? Is on the 50 centimeter mark. So it's on that 50 centimeter mark that you hold that ruler, that the whole weight of the ruler will be concentrated on. So please, let's understand the concept of what? Center of gravity. It is that point on a body where the whole weight of the body appears to be what? To be concentrated on. Do you understand? Don't worry, we'll look at them at the ending part of this class. We'll look at more, we'll go into more details of what? Center of gravity. So those are things that you should note. And also note that the meter rule or the plank in question can also have a weight. There are some questions that they will give you. They will say, okay, this meter rule is a massless meter rule. But there are cases where you even need to even find the weight of the ruler. Because the ruler, of course, has mass now, it has weight. Of course, it has weight. So you might be asked to what? To find the mass of the ruler. And note that if the ruler has a weight, if they say, okay, it is not weightless, it has a weight, the weight will act on the what? On the 50 centimeter mark, because that is the center of gravity where what? The weight appears to be concentrated what? On. So look at this question. A body of mass 58 grams is suspended at the 20 centimeter mark of a uniform meter rule. And one thing you must know is that there's no way of solving questions under principle of moment that you will not draw a diagram. In most occasions, for you to be able to solve that question adequately, you will have to draw a diagram. You will have to draw a diagram. Even if it's an OBJ exam that you don't need to show your workings, you still have to just you have to draw a diagram to be able to get the correct answer. So that's why I say I'm drawing diagrams here and there. So a uniform meter rule, this is our uniform meter rule. A body of 58 grams is suspended at the 20 centimeter mark. So it is a meter rule. From here to here is what? 100 centimeter. Then a body of 58 grams is now suspended at the 20 centimeter mark. Let's call from here to here 20 what? Centimeter. Then we have a body of what? 58 grams suspended what? Here 58. The meter rule is now adjusted. Now, what you must know is that if a meter rule has no weight hanging on it, Eh? Where you will pivot it and it will stand is the 50 centimeter mark. A normal meter rule. Where you will pivot that meter rule, I mean where you do something like this and it will stand, is what? Is the 50 centimeter what? Mark, because that's the center of gravity. That is if there is nothing hanging on it, no mass, no weight, no force hanging on it. Do you understand? So it will be what? It will be pivoted at the what? At the 50 centimeter mark. But if any extra force, any extra weight is not added on it, you will have to adjust the what? The pivot. You have to what? Adjust, you have to adjust the what? The pivot. So you're like, the meter rule is adjusted on a pivot because the pivot can almost stay on the 50 centimeter mark because a mass of 58 gram has been what? Has been added. So it displays the equilibrium. So that pivot must now find a new equilibrium what? Position. So the meter rule is now adjusted on the pivot until it settles horizontally at the 40 centimeter mark. So when this meter rule was readjusted, the pivot now settles on the 40 centimeter what mark. So let's call from here to this point. Okay, let me clean this. From here to this point, from here to this point here of course, to be what? 40 centimeter. So it settles horizontally on the 40 centimeter mark. Determine the mass of the ruler. So in this question, we are asked to find the mass of the ruler, which might look surprising to you, but it's not, because they are saying here that the ruler also has a what? A mass. And I told you that the mass of the ruler will be acting on the center of gravity. Please note, the center of gravity cannot change. Even if you adjust the pivot to another position, the center of gravity still remains the center of gravity. And that is where the weight we act on. You understand? That is where the weight we act on. So like determine the mass of the meter rule. Determine the mass of the meter rule. So the mass of the meter rule will be acting at the what? At the point of the center of gravity, which is what? 50 centimeter. So from here to here, let us add small. So from here to here can be what? Can be 50. So let's put it here. M, the mass of the ruler. Let's say from here to here is 20, from here to here is 40. Why from here to here is what? 50 cm. So that's where the mass of the ruler is what? Is acting. So now we now have what? A moment, kind of. You understand? So what to do is that we use the principle of what? The principle of movement, where the sum of the clockwise moments must be equal to the sum of the what? Anti-clockwise moments for that body to be in what? In equilibrium. So how do we do that? Remember, we are looking for the mass of the ruler. The mass of the ruler is also acting. So it is involved because it's what? It also what? It's a mass, so it is involved in this moment of a thing. So the mass of the ruler or the weight of the ruler is what? Is acting downwards here. Just like this one too is acting what? Downwards. They are both pulling. They are both pulling. So they can make the ruler to be in equilibrium. So I might be using mass and weight at the same time, but it depends on what we are giving the question. You get? So we are giving mass in the question. We use the mass, but we can convert the mass to weight or to force. Understand? But let us use mass as it is because we're after the what? For the mass of the ruler. So clockwise moments, this is anti-clockwise moment. So we equal to what? Clockwise what? Moment. So that will be what? 58 times what? The distance. So now, what is the distance from here to here? Of course, it is what? It is 20. 58 times 20 is equal to what? M times what? What is the distance between here and here? That is 50 minus 40. From here to here is what? 40. So that is 50 minus 40 will give you what? We give you 10. From here to here is what? 20, because from here to here is 40, from here to here is 20. So the distance between here and here is what? 40 minus 20 to give you what? 20. So let me do it like this. 58 times 40 minus 20. This one is what? M times 50 minus 40. You understand? So that is 58 times 20 divided by what? M times 10. So M will be equal to what? 58 times 20 divided by what? 10. So I think there should be 116. Yeah, 116 what? Gram. So the mass of the ruler is what? 116 what? And 16 gram. 116 gram. Very, very simple. Very, very simple. Just understand the concept and you to try more questions in your leisure time. So let's look at the next question. The next question says that a uniform bar 50-meter long. Now, in this case, this is not more a meter rule again. This is now a what? A uniform bar. The uniform bar, 50-meter long, is balanced on a pivot. So let me clean this part. So you can pause and look at it again. It's very simple, straightforward. A uniform bar, 50-meter long. So, as I said, you will have to draw. So this is the bar. So the whole length of the bar from here to here is what? 15-meter long. It's balanced on a pivot placed at its midpoint. So if this bar is 15-meter long, if the bar is now balanced on a pivot at its midpoint, so the midpoint will be here 7.5. The midpoint is like the middle. So here is what? 7.5 what meter. From here to here, 7.5 meter, and from here to here is what? 7.5 meter. So this is what? The midpoint, and that is where it was what? It was pivoted. So a boy of mass 55 kg sits on one arm of the bar at a point 5 meter away from the pivot. Where's my blue marker? So see it here. A ball 5 meter, a boy of mass 55 kg sits on one arm of the bar at a point 5 meter away from the pivot. So it's saying that a boy now came and sits down what? 5 meter away from the pivot. So this is the pivot. So 5 meter away from here. You can do it here too, but me like 5 meter away from here. So that'll be what? 5 meter. Let's check what the boy is sitting. So the boy is sitting what? 5 meter. Let me use the blue marker. The boy is sitting where? 5 meter. And the boy mass is what? 55 kg. So the boy is sitting down here. This is the boy. 55 what? Kg. It's now what? 5 meter from what? The pivot. So if the boy is now 5 meter away from here, that means this point will be what? 7.5 minus 5. Here will be what? 2.5 meter. So from here to here is what? 2.5 meter. It's that simple. 2.5 meter. So let's continue. What mass can be placed 2 meters from the other end of the bar to keep the bar horizontally? So we're now asked that which mass can we place 2 meters from the other end? 2 meters from. So if they are saying 2 meters from the other end, they mean that what? 2 meters. Just switching markers anyhow. 2 meters from here. 2 meters what? From here. So they are asking that how much mass can we place at this position to make this ruler what? Balance horizontally. So that is what we're looking for. Let's call this. Should we call it? Let's call it X. So we're looking for what? For X. For the X kg that will put here, that will make the what? The ruler or the bar balanced. You understand? So let us solve. Right now, this is that we are solving problems on equilibrium, on moments. When you draw the diagram and you have done it to this extent, getting the answer is very, very easy because you've done the critical aspect of it. So getting the answer is just very, very easy. And just more of subtraction, division, multiplication. So, of course, some of Anti-clockwise movements will be equal to what? Sum of what? Clockwise what? Movements. So what is coming like this will be equal to what? What is what? Going like this. You understand? My mic is still on. So let's see how this weight is acting. They give us the weight of the bar. They did not give us the weight of the bar, so we will not use it. We will not use it. We will not give it the weight of the bar, so we will not use it. So 55 kg times, what is the distance between year to year? Is what? 55 kilogram times what? Times 5. Why the distance from year to year is what? This is 7.5 meter from year. Year to year, 7.5 meter. Year to year is 2. So to get year to year is what? 7.5 minus what? Minus 2. That is what? 5.5 meter. So this is what? This will be x times, this is x kg times what? 7.5 minus 2 give what? 5.5 meter. Just break it down for you. So that will be 55 times 5 is what? I'm exhausted, oh, tired. So 55 times 5 will give you what? 275 equal to what? X kg times what? 5.5, right? So x kg equal to what? 275 divided by what? 5.5. So you get what? You get 50. That's your answer. 50 kg will be your answer. Meaning that if you put 50 kg here, at this point, 2 meters away from this end, this body, this bar will be in what? In equilibrium. You can see that the major mental work was done at this point here of discovering where this is, where this is, where that is. So that's just it. So we'll look at 3 more questions and we'll call the principle of movement over. Because, of course, no matter how good I am, I can't solve all the questions for you. You still have to do some questions on your own. You have to solve them on your own to get you comfortable with them. So I can't solve all the questions that there is on this topic. So you still have to do your own assignment, your own personal study. But this way may I come in handy to explain to you the basics, the fundamental, and to even dive deep a little bit. So let's move on to the next examples. You can pause. So let's look at this question. Look at this question. You know, I was talking about you having more than one force at one particular end or one mass at one particular end. So let's look at this first question. They just give us this diagram. They don't put any, I don't want to add too much story. So this diagram is just telling that this is a plank and you have a 50 kilogram weight suspended at a point of 1.5 meter from the pivot, while this unknown mass was also suspended 1.5 meter from the pivot. And this 15 kilogram mass was suspended 2 meter, see, 2 meter from the pivot. So we are asked that to look for the unknown mass. So it's quite simple. See the same principle. Sum of, let me use my black marker, sum of what? Anti-clockwise movement. What's what? Clockwise movement. You understand? So what is the anti-clockwise movement? That is what? 50 times 1.5. 50 times 1.5. That is the only one that we have on this edge. Equal to what? X times. So taking this one, we have two. We have this one for this one. Acting through 1.5 meter. While we have this one acting through what? 2 meter. So it's like what? X times what? X kg times what? 1.5 plus that was the sum of moments. The sum of clockwise plus the must be equal to the what? The sum of clockwise must be equal to the sum of what? Anti-clockwise. 2 plus 15 kg times what? Times 2 meter. So this will be what? 50 times 1.5. Let's give it. I think you give it 75. Let's use our calculator here. Give what? 75. Go to what? 15x plus what? 30. of what plus 30. Yeah. So 75 minus 30 equal to what? 15x. So 45, right? Yeah, 45 minus 3, 4, yeah, 45 equal to what? 15x. By 15 by 15. X equal to what? 3 kg. So this is what? A 3 kg mass. This will be a what? A 3 kg mass. I don't know why I'm doubting. Correct now. Yeah. A 3 kg mass. I'll check. There should be no mistake there. A 3 kg mass. So we've gotten the unknown mass. The unknown mass is what? 3 kg. So let's look at this one. This one is quite looking new because there's an angle involved and it's not actually difficult. It's very, very simple. Very, very simple. So this diagram says you find P. There's no story around it. So this is the pivot. This point. Let me see the blue marker to be circling it so you can see clearly. So the pivot is at this point, and they said there's a mass that was dropped here, and that mass is weighing 40 Newton and is acting what? Downwards. So the distance between the pivot and this 40 Newton weight, 40 Newton block is what? 20 centimeter. While the distance between this one too is also a force acting, but it's pulling this bar at an angle of what? 30 degrees. So the distance between the force acting at an angle and this bar is what? Is 30 centimeter. Is 30 centimeter. So we're asked to what? To find P. So we're actually going through the normal procedure of saying anti-clockwise moment should be equal to what? Clockwise moment. But one thing is that since this force is acting at an angle, it has two components. It has an horizontal component and it has a vertical component. So which of them will we take into consideration for this question? We'll just take the what? The vertical component, because the horizontal component is literally just pulling it this way, which will have no effects. So the horizontal component will have no turning effect. Only the vertical component that will have what? A turning effect. So we'll use what? The vertical component. So the vertical component of this P is what? P sine 30. Why the horizontal one will be what? P cos 30. You understand? Because this is the angle. So the horizontal component is what? P cos 30. Why the vertical is what? P sine 30. So we're only using the what? The vertical. P sine 30. So we can redraw this thing. Let us redraw it. So if I redrawing it, we now see something like this. This will be P sine 30. Then you have your 40 Newton block here. Then you have your pivot here, 20 centimeter. The distance from here to here is 30. So it's that simple. So let's take clockwise moment and anti-clockwise moment. So this P sine 30 will be going this way, while this 40 will be going this way. So this 40 Newton will be going clockwise. This P sine 30 will be going what? Anti-clockwise. We have to find P. So which is anti-clockwise? There's P sine 30. So at what distance is it acting? Of course, they will act at a distance that must meet the what? The turning point. At a distance that must meet the what? The turning point. So it is not just from here to here, it is from here to obviously here. So what the distance between here and here is what? 50 centimeter. Why from here to here is just what? 20 centimeters. So that 40 times what? 20 centimeter. So what is P? We don't know. Sine 30 is what? 0.5 times what? 50 centimeter. Equal to what? 4 times 2, 800. So to get P is equal to what? 800 divided by 0.5 times 50. So 0 cancel 0, 5 here 1, and 5 here will be 16. And we have 16 divided by 0.5. We get what? 32, I guess. Yeah, you get 32. So that will be 32, 32 Newton. 32 Newton as a force. 32 Newton. So that's it. So our next agenda is quite simple. We're looking at the last part that I'll be touching. So, glory be to God. So, one thing I'll tell you is that if you are someone that you are writing your UTME, you are writing your post UTME, or your NECO, your WAEC, do well to enroll for our tutorials or BACS Scholars Academy. And trust me, we've produced massive and great results in students. Most of our students in this year, this 2024, they had above 300 in JAMB. We had as high as 358. Our students, we had 343, we had 344, we had 351, multiple 340, 350, 330, 320, and majorly above 300. So if you desire that kind of result, if you have written JAMB multiple times and you're on the verge of giving up on yourself, you're on the verge of saying, oh, maybe school is not for me, I tell you that please try Obak School Academy by enrolling for their tutorial. A link for you to get access to us will be dropped in the description of this video, and even a link for you to even get access to me personally, my private DM number, one-on-one. So please do well to join Obak School Academy because we are the best at what we do. We produce results and there are evidences of those results if you want to do it. If you want to see them, you understand. So at the last part of this topic, it has really been a long ride. It has really been a long ride. So we've been recording overnight. So I've explained what center of gravity is. The center of gravity is that point in an object where the weight of the body is what is appeared. Where the weight of the body appears to be concentrated on. Where the weight of the body what appears to be concentrated. So if you are looking at at a circular board, if you are looking for where the center of gravity is, you are looking for the particular point on a circular board, the center of gravity is what? At the center. At the center. If it's a meter rule, the center of gravity is what? Also what? At the midpoint or at the center. You understand? If it's a square board, or sorry, a rectangular board, the center of gravity is at the intersection of the diagonals. Can I draw it well? At the intersection of the what? Of the diagonal. So that means what? This is the what? The center of what? Of gravity. So different objects have their own center of gravity. But this one like the easy ones and the and the most common ones that they will ask you if you want to ask you in an exam for your level. So we are looking at what? The stability of what? Of objects. So we are looking at the stability of objects. We have three types of equilibrium. We have the stable equilibrium, we have the unstable equilibrium, and we have the what? The neutral equilibrium. We have the stable equilibrium, the unstable equilibrium, and the neutral equilibrium. So I think I will have to clean the board to explain here. Let me just use here. Let me use here. So the stable equilibrium. So a body is said to be in stable equilibrium if when the body is displaced, it finds itself, it returns itself to its original position. So for example, I don't have anything I can use to create an example, but there have been cases where you add a bucket and you kick the bucket a little bit, and the bucket roll and roll and roll and still returned back to its initial position, to its original position. That was we call what? Stable equilibrium. So it tends to return to its original position when slightly displaced. So an example is number one, a cone resting on its base. If you have a cone resting on its base, if you slightly displace it, it will return back to its normal position. Second one is what? A ball or sphere in the middle of a bowl. So you put a ball or sphere in the middle of a bowl. If you displace the ball will roll back to its what? To its original position. So that's examples of what? Of stable equilibrium. You can go and look them up in your textbooks. You see them. You see more examples. So the next one is on stable equilibrium. Unstable equilibrium. So a body is said to be in an unstable equilibrium when the body is displaced, it is what? It tends to move further from its original position. And that is what we call what? Unstable equilibrium. So if a body is in unstable equilibrium, when you displace it, it will move further from its what? From its original position. And an example of that is what? A cone resting on its apex. A cone resting on its what? On its apex. When you invert the cone, it's now resting on that tiny point. That is what? Unstable equilibrium. The second one is what? A ball or a sphere resting on an inverted bowl. When the ball is now turned upside down, you now put a ball or a sphere. If you don't displace the ball will move away. It will slope downwards because the ball is what? Is inverted. It will not look like letter U. You understand? So you can check out more examples and read more deeper from your textbooks or your notes. So the last one is the neutral equilibrium. So in neutral equilibrium, the body is said to be in neutral equilibrium if when slightly displaced, it tends to come to rest in a what? In a new position. It will come to rest in what? A new position. So that is what? Neutral equilibrium. An example are a cone or a egg resting on their side. So a cone. So if a cone is resting on its side and you just displace it, it can just turn small. And you see that is what? To turn to another position. So that will call what? Neutral equilibrium. When they are slightly displaced, we find a new position. And another example is what? An egg. If you twist an egg when it's resting on its side, to find is what? A new position. A new position. Or even a ball. When a ball is on an horizontal table and you slightly displace it, not too much, just slight displacement, it will find itself in a new what? In a new position. So we've come a long way today, and we've taught a lot. We've touched right from what equilibrium means to this point where we are talking on what? Stability of objects. So we've done various calculations. So it is your duty to go back, revise what has been taught here, watch this video as many times as you can for you to understand. Go back, revise, solve more questions, carry your past questions, solve your questions, and get more familiar with this topic. The more you solve, the more you sharpen your brain to be better at a particular topic. So we've come to the end of this video. If you enjoyed this video, if you still have questions, if you have suggestions for us, please drop them in the comment section. If it helped you, let us see your testimonial, let us see your review in the comment section, your honest review, of course, in the comment section. And make sure to like the video and subscribe to our channel, and turn on your notifications for more video that will be coming up. And remember, this is Obak School Academy, where we raise what? We raise scholars. And one more time, for the last time, if you know you are registering, if you know you are seeking admission in any year you are watching this video, of course, we'll surely be, we'll be on point. So if you are seeking admission to any university in Nigeria, maybe you want to write JAMB, or you want to write a nursing school exam, you want to write your WAEC, you want to write your NECO, or you want to write your GCE or your post UTME, and you want maximum excellence, you want maximum success, I can assure you that when you join Obak School Academy, you are going to get what you enrolled for. You're going to get what you paid for. So join us today. So that's the end of this video. See you in our next video. Thank you.